Hello students, here we have a problem. Induced voltage rotating disk. I get one request from the student. It was really good question, so he requested me solve this problem. Now, it's very interesting question. So let me read the question. The metal disc of 28 centimeter in diameter rotates about its circular axis of the symmetry at an angle speed of 460 radians per second. The disk is situated in a uniform magnetic field of 0.195 Tesla, perpendicular to the plane of disk. What is the absolute value of the induced voltage between axis and the rim of the disk? Now, first of all, it's a metal disc, okay? As you can see, it's not a ring, it's a disc. And it has diameter. Now you have to find induced voltage. Induced voltage between, let's say, is VA from the axis and VB, which is the rim. Okay. Now, if you look at in the other case, basically, you have to find induced voltage. So between these 2 points. Okay, this is, let's say, VB. This is a VA. Okay, VA. Now, there is a couple of ways of solving such a problem. First of all, it's a disk, right? So we know that flux is equal B times A, right? Now the area of this disk is B pi R squared, okay? Now then we have EMF, where actually is dF over dt, but here we can say that flux over time, okay, or period. Or you can say that's B pi R squared. Now the T, 1 over T gives you frequency, right? So we can put here frequency. Then we have a formula where frequency is equal, okay, so the omega is equal to 2 pi frequency, and from there frequency will be omega over 2 pi. So I can put here B pi R squared omega divided by 2 pi. So the pi cancels out, so finally you will have B omega R squared over 2. Okay, this is your final formula. If you plug the numbers, you will get the answer. Now, the second way of solving it is basically you have to consider, so you have a disk. You have a disk, okay, if you just try to imagine this disk. You have to take the very small piece of it, okay? Very small rod, I would say. So this is axis of rotation, this is the rim, and you can take any small place, okay? Small part of it, where I call this one dr, the length of that one. And this, from axis till this small piece, the distance becomes r, okay? Then at this point we have V. Now dr, at this point we have d EMF, okay? The total length of the rod is I would call it L or capital R, okay? So that means we have d EMF is equal to the what is this one? So if you take the model dF over dt, or we have V L, right? Then our V is equal omega omega R. So BVL. So sorry, just one moment. So if you're taking the very small one of it, then this will be dr, okay? Dr is just a small piece of it. Then we have this V is equal omega R, so B omega R dr, okay? Then you have to integrate it from 0 till the R, okay? So that means you will get that EMF is equal B omega R squared over 2. Then if you plug the 0 till the R, you will get B omega divided by 2 This is r squared minus 0. So finally you will get that your EMF is equal b omega r squared divided by 2. So as you can see, in both cases we get the same answer.